find the volume of the solid generated by revolving the region bounded by the curves y equals root x, x equals 4 and y equals 0 about the line y equals -2. Okay, first we want to graph the curves and find the region bounded by those. So a y-axis, horizontal x-axis, y equals root x. So this is the graph, y equals root x, origin, x equals 4. Okay, 1 2 3 4, a vertical line, x equals 4. So this is 4. Now we can find this point of intersection, 4, and the height is now given by y equals root x. So y equals root 4. Root 4 means this height will be 2. Okay, so this point, let me use different color, this is 4 comma 2, and y equals 0. Y equals 0 means x-axis, so x-axis is same as y equals 0. So the region bounded by these three curves is this region. Okay, and we want to rotate this region about the line y equals -2. Okay, y equals -2, so -1 -2. So here is the line y equals -2. Okay, we want to revolve about this -2, and we are using disk washer method. For that we want to draw a sample slice perpendicular to this y equals -2 line. So we want to take a sample disk, in this case sample slice here. Okay, this is the slice now, which has small width here, delta x, small width delta x. That suggests the volume formula later we will be using in terms of x dx. Okay, and this slice could be taken anywhere from 0 through 4, anywhere. Okay, so 0 through 4, and we'll find the area of that washer or disc. We'll see in a moment. Okay, so let me erase that part. Now when we rotate this sample rectangle about y equals -2, then we'll have a disc with hollow inside, we call washer. Okay, let me draw over here. So we'll have this outer disc, inner disc, there is a hollow inside, and that's the line. Here is the center, so y equals -2. So this line is y equals -2, and we have, okay, this part. So we are interested in finding the area of this washer. This will be a washer, so we are interested in finding the area of this washer. That goes into the volume formula. So we need outer radius, this uppercase R, and inner radius lowercase r, from this axis of rotation to inner curve and axis of rotation to outer curve. That's the r and r. So let's, what is r and what is r? Okay, the outer radius, let's go back to the original question here. So this distance from outer, this curve to the center axis of rotation, this is r. Okay, we know from this x-axis to the outer, that's the y value. This is always height is given y, which is root x, and from this x-axis to y equals -2, this distance is fixed. Okay, this is 2, here to here this is 2, and here to there that's y. Okay, this is y direction, y is given by root x. So from the axis of rotation here to here, this is always fixed, that's 2. In fact, we found lowercase r, that's 2, that's fixed. Now outside is 2 plus this y is given by root x, so 2 plus root x. Okay, let's look at one more time. We were trying to find the outer and inner radius. Okay, so outer radius means from the axis of rotation to the outer part. Outer means this curve. So here to here, this is horizontal line, y equals -2 and y equals 0, or x-axis. This is always fixed. This is 2. This is 2. So the lowercase r is 2. Inner radius 2, and outer, this 2 plus more. This changes. This if we had taken this sample rectangle here, that would change. In any case, this is y direction, y curve. Y is given by root x, so 2 plus root x. Now the area of this washer will be, it's like the circle, so area is given by a in terms of x is area whole pi r square, that gives the all area minus there is hollow inside, so minus pi r square. So we have to subtract the area of inside. Okay, which is, we can factor pi out. R square, r is 2 plus root x, 2 plus root x quantity square, minus pi is out, r square is 2 square, 4. Let's simplify. Pi 2 plus root x is square, multiply 2 plus root x by itself. Okay, do on the side, use FOIL or square it, then you get 4 plus 4 root x plus x minus 4, and 4 and 4 cancel, so we have pi outside 4 root x plus x. Okay, that's the area of the washer. Now we will be using this volume formula to calculate the final volume. Okay, thus the volume is given by 0 to 4. I think that's correct, right? Yeah, 0 to 4, because the sample rectangle could be taken anywhere from 0 to 4. And area we just found here, that area is pi, we can pull pi outside, pi 4 root x plus x dx. Pi is already outside. Let's find the antiderivative of 4 root x. 4 is 4 root x means x raised to 1/2. Then antiderivative of x raised to 1/2 is x raised to 1/2 plus 1, 3/2 divided by same thing, 3/2 plus x, so x is square over 2, and we want to go from 0 to 4. Okay, pi outside, 4 times 3, this is 3/2. When we move, it goes top, becomes 2/3. 4 times 2/3, so 8/3. And at the same time, I want to evaluate this function at 4 and upper limit minus lower limit, evaluate this at 0, that becomes just 0, so no need to mention. 8/3 times 4 upper limit, 4 raised to 3/2 plus x is square, that means 4 is square, 16 divided by 2, 8. That's the upper limit, minus plug in 0, we get 0, so no need to mention. So pi 8/3, 4 raised to 3/2, 4 raised to 3/2. Okay, 4 is 2 squared, square cancel, so 2 cube, it will be 8, or you can use your calculator. 4 raised to 3/2 is 8. This is 8 plus 8, so pi 8 times 8, 64/3 plus 8. Pi 8 is how many thirds, because we have 64/3, 8 times 3, 24/3, so 64 and 24, that's 88/3, so 88/3. So the final answer is 88/3 pi cubic units. Okay, that because it's volume, cubic units.